Hi everybody, we will learn how to integrate integral sine of ln x times dx. So first what I wish to do is I would like to make the substitution. Let ln x be equal to u. So if you were to differentiate this is going to be 1 over x times dx is going to be equal to du. Now I need only dx, so I'm going to rewrite this as dx is equal to x times du, right? Now we have actually made this substitution, ln x is equal to u. Now from logarithms there is a property. If you got something like this, say log a to the base b is equal to y, then you can rewrite this as a is equal to b raised to the power of y. Now this is also applicable to, say for example, to natural logarithms, which is actually written in this fashion. Now I'm just taking this as an illustration. Ln m to the base e, if you happen to be seeing something of this nature, then you can very well rewrite this as m is equal to e raised to the power of t. So there are two forms I have given you, one in logarithm, which is also called as the common logs, and the other in natural logs. So having mentioned that, this is actually to the base e. So utilizing the formula, I can rewrite this as x is equal to e raised to the power of u. So wherever x is seen, I can very well substitute it as e raised to the power of u. So this is going to be dx is equal to, in place of x is going to be e raised to the power of u times du. So this is a very important substitution. So if I were to take this as 1, therefore I can rewrite 1 to be as, so this is the original question, integral sine of ln x times dx. This is rewritten as integral sine of, in place of ln I'm going to place u, in place of ln x I'm going to place u, in place of dx I'm going to be placing e raised to the power of u times du. So this is what we have got. So let me rewrite this in this fashion, sine u times e raised to the power of u times du. Okay, so now I can use integration by parts. That's the best way. So for that, what I will do, I will design two columns. I am going to apply Bernoulli's technique. So for that I need a D column and an I column. In this place I am going to integrate, in this place I am going to differentiate. So I am going to take e raised to the power of u for differentiation, for the column under differentiation, and I am going to take sine u for the column under integration. So every time you integrate the quantity here, you place them here. Every time you differentiate the quantity here, you place them below. Now the thing is that we start with the alternating sign. We start with positive, then follow it up with a negative, and then a positive. And I think that would be sufficient enough for us. So I differentiate e raised to the power of u, I get e raised to the power of u. I integrate sine u, I get negative cos u. Now I differentiate e raised to the power of u, I get e raised to the power of u. I integrate cos u. When you integrate cos u, you are getting sine u. Since you got a negative sign, you just place the negative sign and place sine u. So when you are writing the terms have to be written in this fashion, right? In this fashion we write this. So this term into this term, with the leading sign being positive, followed by a negative sign. And then finally, since this is the last term, I would be actually writing this term in this fashion. Okay, so this term will be under integration. So have that in mind. So let me show that to you. So this is equal to, on the left hand side, what you got on the left hand side, you have integral. I'm going to rewrite it as e raised to the power of u times sine u times du. This is what you got on the left hand side. On the right hand side, you start with e raised to the power of u. You multiply it with cos u with a negative sign, so this is going to be negative cos u, and then followed up with negative negative positive e raised to the power of u times sine u, and then you got a positive times negative, that's going to be negative e raised to the power, we need to have an integral sign for the last term, so integrating e raised to the power of u times sine u times du. I hope you are able to catch this. Now I can push this quantity to the left hand side. That would mean I have e raised to the power of u times sine u du, positive integral e raised to the power of u sine u du. On the right hand side you have negative e raised to the power of u cos u. So I'm going to write the positive term first. So this is going to be e raised to the power of u times the sine u negative e raised to the power of u times cos u. You can add these two together. That would give me 2 times integral e raised to the power of u sine u du is equal to, I can take e raised to the power of u out. This is going to be sine u negative cos u. Now you can push the 2 to the right hand side. So this is going to be e raised to the power of u over 2 times sine u negative cos u. So this is the quantity that we have. Actually, we wanted this quantity, right? On the left hand side, you got e raised to the power of u times sine u times du, right? This is what we have got. Now you can revert back to the x components, right? You can state it here, since u is equal to ln x. So if you were to rewrite this, right, this is already got. You don't need to touch this. So this is the solution that we are looking after or looking for. So you can place the solution. And not only that, e raised to the power of u is equal to x. So that is also an important substitution you can make. So this is going to be equal to, in place of e raised to the power of u, you got an x, you got a 2 there, place that, times sine of, in place of u, you place ln x followed by negative sign, and then you got a cos of ln x. So this is the answer. Of course, it is not complete unless you place the arbitrary constant c. And that would wrap up, and it's a good place for us to stop. So this is a beautiful question. I hope you enjoyed this, and have a good night, everybody. Thank you.